Welcome to the boardroom. I am your managing director for today's Executive Pitch Masterclass, and in this explainer, we are tackling one of the absolute highest stakes client briefs in your entire academic portfolio, the Cambridge AS and A-Level Mathematics 9709 syllabus. Specifically, we're going to master the transformation of logarithmic and exponential functions into linear form. Now, you might be wondering why on earth we're treating an A-level math paper like a high-level corporate consultation. Well, it's simple. Approaching your exam paper with the absolute clarity, rigorous structure, and undeniable authority of an executive consultant is exactly what the principal examiners are looking for. They don't just want the right answer, they want a compelling, watertight case. So today, I am going to take you through a complete, step-by-step boardroom blueprint designed to secure maximum marks on your final paper.
Okay, let's dive right into this and look at the actual stakes of our proposal. You know, the difference between a B and an A star often comes down to mastering this exact multi-stage analysis. It is literally the ultimate grade differentiator. To really demonstrate how to navigate this, I want to introduce you to two archetypical junior consultants on our team. First up, we have consultant Alex. Now, Alex is an absolute numbers whiz, armed with excellent data points, but completely lacks executive summary delivery. The mathematical working is, frankly, chaotic. Then, on the other hand, we have consultant Sam. Sam is a highly persuasive speaker who writes beautiful, flowing, concluding sentences, but completely lacks the physical mathematical assets and case study backing to actually prove the point. Let me be clear, neither approach will win you the Cambridge A-star contract, but over the course of this explainer, we're going to merge their strengths to build the absolute perfect pitch.
Here is our masterclass agenda for today. 1. The A-star differentiator. 2. The procedural framework. 3. Securing method marks. 4. Top examiner warnings, and finally, 5. Evaluative exam strategy.
Kicking things off with Section 1, the A-star differentiator.
In the corporate world, we call this the barrier to entry. Examiners specifically target linear transformations to separate those top-tier candidates from the rest of the pack because it requires true, high-level cognitive processing. Our core business problem here is converting unpredictable, nonlinear curves, like y equals k a to the power of x, into readable straight lines. So how do we do it? By applying logarithms to both sides. It's like applying a clarifying lens to market volatility. If you take the log of y equals k a to the power of x, applying your log rules gives you log y equals x log a plus log k. And suddenly, as if by magic, that maps perfectly onto the classic equation of a straight line, y equals mx plus c. Your large y becomes log y, your gradient m becomes log a, and your y-intercept c becomes log k. We are literally turning unpredictable exponential chaos into a highly readable, strictly linear trend that we can actually analyze.
And this right here is exactly where our junior consultants diverge. Sam often falls into the trap of superficial breadth, trying to cover way too much ground without proving the underlying math. It's like a puddle, right? It's wide, but it's incredibly shallow. Alex, meanwhile, provides the raw math, but with absolutely zero analytical depth, completely missing the foundational roots of the problem. You see, the Cambridge syllabus heavily prioritizes deep, interconnected conceptual understanding that you can easily transfer to completely unfamiliar, out-of-the-box exam contexts. You absolutely must demonstrate a mastery of these fundamental mathematical principles. You have to know exactly why taking the logarithm of a power pulls that exponent down to become a multiplier. Just reciting a formula from memory? That's not going to cut it in the boardroom.
Moving right along to Section 2, the procedural framework.
I want you to imagine Consultant Alex and Consultant Sam standing in front of the interactive wall display in our boardroom, intensely debating how to map out this 5-step standardized sequence for tackling any examination question. They are optimizing their pitch to ensure total compliance with assessment objectives AO1, AO2, and AO3. We have to treat the exam prompt like a physical mission. Step 1, deconstruct the question to identify the key deliverables. Step 2, extract the critical data points. Step 3, select your analytical framework. This means mathematically deciding on the spot if you're applying natural logarithms, ln, or base 10 logs, which completely depends on whether your given equation uses Euler's number E or other constants. Step 4, execute your analysis with crystal clear, precise mathematical notation. And finally, Step 5, present your final deliverables using the correct formal terminology. Executing this exact framework establishes absolute, undeniable structural credibility with the examiner.
Which perfectly tees up Section 3, securing method marks.
Now, before we audit our consultants' work to see how they're doing, a quick but crucial directive.
To ensure your academic portfolio remains highly competitive, subscribe to our channel Ace the Exams at the handle @AceTheExams and enable notifications for our weekly consulting insights. Okay, let's resume. Our consultants Alex and Sam have just encountered a massive, critical flaw in their mock proposal essay. The executive board, our examiners, are completely rejecting it. Why? Well, look at the core flaw staring right at us. They aren't showing they're working. They've completely failed to align their syntax with the Peel formatting matrix: point, equation, execution, logic. In Cambridge exams, calculating the y-intercept or the gradient purely in your head means absolutely nothing to the board. If you cannot show exactly how you arrived at your valuation step by step, they simply won't trust it. You must identify the elements, visibly apply those logarithmic principles on the page, and execute the analysis so clearly that anyone could follow your logic.
And this ties directly into the single most critical tactical insight we've pulled from the principal examiner reports. Listen to this. Even if your final answer is entirely wrong due to some minor calculator slip-up under pressure, method marks can absolutely save your life. Executing your analysis with clear working and proper notation captures vital partial credit. It is an essential, non-negotiable risk management strategy. It literally prevents a total mark wipeout just because a basic arithmetic error occurred during your final, high-stress subtraction. By showing your work, we are securing our investments.
Let's pivot now to Section 4, Top Examiner Warnings.
All right, it's time for a live audit workshop. I want you to imagine a giant 60-second visual timer ticking down on the boardroom wall. We are doing a rapid-fire risk assessment of the exact trapdoors where candidates just needlessly bleed marks. First major risk: confusing cause and effect. Students routinely misidentify which variable is independent and which is dependent when setting up their large X and large Y axes after taking the logarithms. It derails the whole pitch. Second risk: forgetting to check format and presentation. You absolutely must verify your results and format them exactly as the client brief, the question, demands. Third risk: providing answers that are not specific to the given context. If the equation models population growth over time, your final constants must be explicitly explained in that exact real-world scenario, not just left as abstract letters.
Let's look at a concrete case study comparison right here. This is exactly where you lose structural credibility. On one side, we have a completely botched surface-level answer that totally ignores formatting. It's just a random chaotic jumble of lowercase x's and y's with absolutely zero stated assumptions. The examiner looks at that and sees pure liability. On the other side, we have a top-tier, executive-level analytical response. This response correctly verifies its results and presents the final equation using the original variables if requested. And practically speaking, that means doing the work of mathematically substituting your large X and large Y back into natural log of X and natural log of Y before boldly stating your final answer. This level of precision, that is the undeniable hallmark of an elite consultant.
And finally, we arrive at Section 5, Evaluative Exam Strategy. This right here is your Executive Framework Summary Checklist. This is the exact moment where consultant Alex and consultant Sam finally merge their skills into a flawless presentation. Alex brings the rigorous, indisputable mathematical evidence, and Sam brings the brilliant, overarching evaluative thinking. Top-scoring candidates consistently demonstrate this evaluative mindset. When you look at the linear model you've just created, you need to step back and mentally question the mathematical assumptions you've made. You must identify any evidence limitations, for example, pointing out that perhaps the linear trend only realistically holds true for a very specific, limited range of X values. You have to consider alternative interpretations and flawlessly justify every single mathematical decision with hard, undeniable evidence from your own working. That, my friends, is exactly how we close the deal.
Our junior consultants have successfully pitched their polished, high-scoring final draft, and now the brief is officially handed over to you. I want you to treat every single exam question like a high-stakes client proposal. Show every step of your working to ruthlessly secure those method marks, and always evaluate your mathematical findings. Before you head out to the front lines to tackle those logarithmic and exponential functions, remember to subscribe to Ace the Exams at the handle @AceTheExams, enable that notification bell so you never miss a critical briefing, and drop a comment below with your current academic level and your target subject. Class dismissed, but I'll leave you with this one final provocative thought. If a simple logarithm can bend exponential, volatile chaos into a straight, perfectly predictable line on your exam paper, what other massive, unpredictable trends in the real world are just waiting for you to find their linear form?